The Milky Way, a shimmering ribbon of stars in the heavens, easily visible on clear moonless nights away from city lights. The name Milky Way comes from Greek mythology. Zeus, the father of the gods, had secretly put his illegitimate son to the breast of his wife Hera. Woken by the boy's sucking, she tore him away, whereupon her milk sprayed over the sky. Hence the Greek name Kyklos Galaxius, or Milky Circle, which in turn leads to our word galaxy. In about 400 BC, the Greek philosopher Democritus came to the conclusion that the shimmering ribbon must consist of myriads of stars too dim to be seen with the naked eye. What was needed was an optical instrument to bring them nearer. The telescope was invented in the small Dutch town of Middelburg on the island of Walcheren in the early 17th century. Middelburg was known far beyond the borders of the Netherlands for the quality of its opticians. One of the town's most respected spectacle makers was Hans Lippershey. In 1608, he applied to the States General in The Hague for a patent for a telescope consisting of a combination of concave and convex lenses. Since then, Lippershey has been considered the inventor of the telescope. However, the fame of the instrument was due to another man, Galileo Galilei. He was born in the Italian city of Pisa on the 15th of February 1564. His father sent him to study medicine, but he was vehemently opposed to the obsolete medieval points of view he encountered, and made no secret of his contempt. Instead, Galileo found intellectual fulfillment in mathematics. At the age of 25, he was appointed professor of mathematics at the University of Pisa. In the spring of 1609, Galileo, by now a professor at the University of Padua near Venice, heard about the new magnification tube that had been invented in Holland. Clearly, someone had also told him how the instrument was made. Soon, Galileo had not only copied the device, but improved it. Gradually, he achieved better and better magnification. This achievement was admittedly due less to his own knowledge of optics than to the precision work of the Venetian lens makers who supplied the respected professor with his instruments. Galileo had access to the very best lenses of the age, and he tested out various combinations until he had constructed a model with a magnification 30 times that of the Dutch prototype. On the 21st of August 1609, Galileo demonstrated the 60-centimetre long instrument on the Campanile in St. Mark's Square in Venice, at the time a major maritime and commercial power. And just 3 days later, he presented it to the Doge, the city's ruler. The Doge was well aware of how useful this new instrument would be to his fleet. He rewarded Galileo handsomely, giving him lifelong tenure and tripling his salary. In the Dutch, or Galileo telescope as it is also known, a convex objective magnifies the image by concentrating the light. The rays of light are directed towards the eyepiece or ocular, which consists of a concave lens. The concave lens spreads the rays out again, so that they are parallel when they reach the eye. Galileo made his first telescopic observations of the night sky as early as 1609. When he pointed the instrument at the Milky Way, he saw that the white veil consisted of countless shining stars. It was an overwhelming discovery. Galileo documented his observations, which were later published in his work Sidereus Nuncius, or Stellar Messenger. He wrote,
"The Milky Way is nothing other than a collection of countless stars in great accumulations. For wherever one looks, The eye is immediately confronted by a huge number of stars.
In this way, Galileo confirmed the notion of Democritus, who suspected that the Milky Way consisted of innumerable stars. But Galileo had made a whole series of other observations. He had seen the craters on the moon's surface and detected the phases of Venus. His most spectacular discovery, however, was of 4 of the moons of Jupiter. If these revolve around Jupiter, they confirm the Copernican heliocentric worldview that puts the Sun, not the Earth, in the center of the universe. The old Earth-centered system, supported by the Church, implied that everything revolved directly around the Earth, but Jupiter's moons clearly did not. The discovery of the moons of Jupiter was therefore a thorn in the flesh of the Church. Galileo was well aware of the danger. In 1616, the Holy Inquisition warned him not to propagate the Copernican system any further. However, he continued to advocate the heliocentric worldview, was put under house arrest, and finally forced to recant. Eppur se muove. But the Earth does move, Galileo is said to have murmured these words as he left the tribunal. Humiliated and disappointed, he abandoned his astronomical studies. The Milky Way was largely forgotten. Most astronomers in those days were interested almost exclusively in our solar system. The next man to take an interest in the silvery ribbon in the sky was a philosopher, Immanuel Kant. In 1755, this German scholar proposed a theory which assumed a disk-like accumulation of stars.
We are within this disk, and when we look along the equatorial plane, we see innumerable stars, the Milky Way.
He also assumed that the Milky Way rotated around its own axis, just as the planets revolve around the Sun. But as luck would have it, this early work by Kant disappeared from view when his publisher went bankrupt. It was not until the German-born English astronomer William Herschel built large and powerful telescopes that the Milky Way became an object of scientific interest once more. Herschel looked at the sky region by region and counted the stars. In 1785, he finally published his first star chart. His observations reinforced Kant's thesis that the Milky Way was a disk. According to Herschel, the Sun was in the middle of a lens-shaped structure whose diameter must be 4 times its thickness. In saying this, he was for the first time giving the Milky Way a definite size. For a long time it had been thought to be infinite. Herschel deduced the distance of the stars from their brightness. The results were distorted, though, by the enormous clouds of dust and gas which he had not allowed for, even though they absorb much of the light. The actual shape of the Milky Way was finally identified by an American astronomer, Harlow Shapley, at the start of the 20th century. Shapley worked at the Hale Observatory on Mount Wilson, which at the time had the world's most powerful telescope. While observing, he came across what are known as globular clusters, very dense accumulations of stars in a small space. He succeeded in determining the distances of 69 of these clusters. As the globular clusters were further away than any other visible stars, Shapley assumed that they formed the outer fringe of our home galaxy, the Milky Way. Because of their distribution and their position relative to the Sun, he concluded that the Sun was not at the center of the Milky Way, but rather on the outskirts. Shapley thus literally broadened our horizons, even though he overestimated the distances involved by a factor of 2. Today we know that the Milky Way has a diameter of 100,000 light-years and that the Sun is 27,000 light-years from the center. Shapley's mistake led him to the belief that the Milky Way was indeed the universe. But in 1923, his fellow countryman Edwin Powell Hubble was able to prove that there were other galaxies beyond the Milky Way. Basically, there are three types. First, irregular galaxies with no clearly discernible structure. Then there are elliptical galaxies. And finally, the spiral galaxies, with clearly recognizable spiral arms. Most of our neighboring galaxies, like the one in Andromeda, are spiral galaxies rotating about their own axis. It is assumed that the Milky Way does the same. In fact, by observing the speeds of the stars, it can be shown that the Milky Way does indeed rotate. The speed of rotation first increases as you go outwards, then falls off again towards the edge. This differential speed is what causes the typical spiral shape. It was thought for a long time that the Milky Way must be a spiral galaxy, but the proof only came in 1951. Walter Baade, a German astronomer, had discovered that certain particularly luminous stars only occur in the spiral arms. The American astronomer William Morgan searched our own Milky Way for regions in which these bright stars occurred. By 1951, he had evaluated the distances of the regions he had investigated and compiled a map. The result is an image of the Orion Arm on whose interior the Sun is located. And also of the Perseus Arm, which runs parallel to the Orion Arm, only it is another 7,000 light-years further away from the galactic center. Morgan also found indications of a Sagittarius Arm. Looked at from above, the Milky Way resembles a windmill. The individual spiral arms are quite clear. They are also the birthplaces of new stars, which coagulate from dust and gas. Our Milky Way contains some 200 billion stars, and in between there are huge clouds of dust and gas which obscure the view. Looked at from the side, the Milky Way resembles a discus. It is surrounded by the so-called halo, which shows the size of the Milky Way when it was still a ball of gas. The halo is also where we find the globular clusters, stars aged up to 13 billion years. Each globular cluster is between 30 and 300 light-years across and contains hundreds of thousands of stars. We know far more about the nature of the Milky Way than we did when Galileo first directed his telescope at the silvery ribbon, and the light of knowledge illuminated the sky for a brief while. But even with the latest technology, vast areas of our galaxy still lie shrouded in darkness. The starry sky still conceals enough mysteries, and with luck, Galileo's heirs will be able to cast light on them one day.